we are not going to use all the libraries we mentioned in the first coding lecture. So let's import NumPy as NP, pandas as PD, and matplotlib.pyplot as PLT. These three are pretty conventional. I probably won't even need NumPy, but it's always good to have it there, ready to lend a helping hand for some operations. Alright, in addition, I'll import statsmodels.api as SM. That's the library we will use when running regressions. Cool. I have all my data in this CSV file called 1.01 simplelinearregression.csv. Let's load it in a new variable called data using the pandas method read_CSV. After running this line of code, the data from the .csv will be loaded in the data variable. As I am using pandas, the data variable will be automatically converted into a data frame. Let's see if that's true. I'll write data and run the line. The result is clear. We have visualized the data frame. There are two columns, SAT and GPA. And that's what our example will be all about. I'll further print data.describe, which is a pandas method to give me the most useful descriptive statistics for each column in the data frame. Number of observations, mean, standard deviation, and so on. We won't put that to work just yet, but it's good practice to use it. Let's explore the problem. So, we have a sample of 84 students who have studied in college. Their total SAT scores include critical reading, mathematics, and writing, while the GPA is their grade point average they had at graduation. That's a very famous relationship. We will create a linear regression which predicts the GPA of a student based on their SAT score. That's quite logical, right? You sit the SAT and get a score. With this score, you apply to college. The next 4 years, you attend college and graduate receiving many grades, forming your GPA. So, that's the timeline. Before we finish this introduction, I want to get this out of the way. Each time you create a regression, it should be meaningful. Why would I predict GPA with SAT? Well, the SAT is considered one of the best estimators of intellectual capacity and capability. On average, if you did well on your SAT, you will do well in college and at the workplace. Almost all colleges across the USA are using the SAT as a proxy for admission. The SAT stood the test of time and established itself as the leading exam for college admission. It is safe to say our regression makes sense. Okay, after we've cleared things up, we can start creating our first regression in Python. This time, we will go through the code, and in subsequent lectures, we will clarify each point. Remember, the equation is y hat equals b0 plus b1 times x1. Our dependent variable is GPA, so I'll create a variable called y, which will contain GPA. Just a reminder, the pandas syntax is quite simple. All I have to do is write the name of the data frame, in this case, data, and then add in square brackets the relevant column name, which is GPA in our case. Similarly, our independent variable is SAT, and I'll load it in a variable x1. Therefore, x1 is equal to data SAT. Okay. It's always useful to plot your data in order to understand it better and see if there is a relationship to be found. I'll use some conventional matplotlib code. Each point on the graph represents a different student. For instance, this is a student who scored around 1900 on the SAT and graduated with a 3.4 GPA. Observing all data points, we can see that there is a strong relationship between SAT and GPA. In general, the higher the SAT of a student, the higher their GPA. Great! Next, we need to create a new variable, which I'll call x. We have our x1, but we don't have an x0. In fact, in the regression equation, there is no explicit x0. The coefficient b0 is alone. That can be represented as b0 times 1, right? So if there was an x0, it would always be 1. It is really practical for computational purposes to incorporate this notion into the equation. And that's how we estimate the intercept b0. In terms of code, stats models uses the method add constant. So let's declare a new variable. X equals sm dot add underscore constant x1. Cool. Right after we do that, we will create another variable named results, which will contain the output of the ordinary least squares regression, or OLS. As arguments, we must add the dependent variable y and the newly defined x. At the end, we will need the fit method, which you can think of as a method that will apply a specific estimation technique to obtain the fit of the model. That itself is enough to perform the regression. In any case, results.summary will display the regression results and organize them into 3 tables. As you can see, we have a lot of statistics in front of us, and we will examine them in more detail in subsequent lectures. Okay, let's plot the regression line on the same scatter plot. That's the best fitting line, or in other words, the line which is closest to all observations simultaneously. So that's how you create a simple linear regression in Python. Pretty cool, right?